Look at the different types of sets now. What are the different types of sets? Let us know now. First of all, what is a set? I shall revise. A set is a well-defined collection of objects. Set is a well-defined collection of objects. Now look at the different types of sets. The first one is an empty set. The first type of the set is an empty set. The set with no elements is called an empty set, which is also called as null set, or it is also called as void set, and it is denoted by set brackets with no elements or the symbol phi. You should read this as phi. Okay? An empty set means a set without elements, or a set with no elements is called an empty set. This is also called as null set, and it is also called as a void set. This empty set is represented by these curly brackets without any element or the letter phi. Example. Now what is an empty set? I may give an example. See here. A is equal to set x such that x is a negative natural number. Is there any negative natural number? No. Natural numbers may start from 1, 2, 3, 4 and so on are natural numbers. In the set of natural numbers you cannot find any negative natural number. Therefore there is no element belong to this set. Therefore it is an empty set. Next is singleton set. Singleton set means a set with only one element is called singleton set. If in any set there is only one element, such set is called singleton set. For example, B is equal to set A. Here how many elements are there? Only one element A. Therefore this set B is called singleton set. Another example. C is equal to set X such that X is an even prime number. The prime numbers may start from 2, 3, 5, 7 and so on. Out of all the prime numbers, only 2 is the even prime number. Therefore there is only one element in this set. Therefore it is a singleton set. And the third one is universal set. A set with all likely elements is called an universal set. A set with all likely elements is called an universal set. And this universal set is represented by U or mu. These two are used to represent an universal set. For example, if we consider the students in your school, the students in your school is a set. Now, at the time of Independence Day or some other sports day or some other sports events, our PD sir used to pick up some students as cricket team and some students as volleyball team and some other students as kabaddi team, like this. Now whole set of students of the school is called as universal set. You can consider it as universal set. Now the set of kabaddi players is a part of universal set. The set of cricket players is a part of universal set. The set of tennis players is a part of universal set. Therefore, if we consider the total set of students in a school is universal set, from this universal set you can pick up the remaining sets. Therefore, the set of students in the school is called universal set. Means a set with all likely elements is a universal set. From this universal set only you can list out the remaining sets. This universal set is represented by U, capital U or mu. In Venn diagram, this universal set may be represented with either square or rectangle. The next is finite set. If the number of elements is finite in any set, if the number of elements is finite or countable, such set is called finite set. For example, D is equal to set X such that X is an vowel. Now what are the vowels? A, E, I, O, U. There are 5 vowels in English alphabet. You can count the number of vowels. Therefore it is a finite set. Here X is such that X is a person on globe. You can count the population of the globe. Though it is a big number, a very big number, you can count the number of persons on the globe. Therefore again it is a finite set. If it is countable, it is a finite set. And at the same time, I may say that an empty set is also a finite set, because you can count how many elements are there in an empty set. You can say how many elements are there in an empty set. In an empty set, the number of elements is 0. It is countable. Therefore, every empty set is a finite set. And the next is infinite set. The name itself indicates if the number of elements of a set is infinite, then it is called an infinite set. Example, n is equal to, n means natural numbers, is equal to set 1, 2, 3, 4 and so on. There is no end. Therefore, it is called an infinite set. How many natural numbers are there? Infinite natural numbers are there. Therefore, there are infinite elements belong to this set. That's why it is called an infinite set. Take this example. S is equal to set X such that X is a star in the sky. You cannot count the number of stars in the sky. Therefore, it is infinite. Whereas you can count the number of persons on the globe. Therefore, it is finite. The next is subset. If every element of a set is also an element of another set, then the first set is subset to the second set. This I shall repeat. If every element of a particular set is also an element of another set, then the first set is said to be subset to the second set. If there are two sets, all the elements of the first set are also elements of the second set, then you can say that the first set is subset to second set. I shall give an example. Here A is equal to set 1, 2, 3 and B is equal to set 1, 2, 3 and 4. Now you can observe every element of A is also an element of B. Every element or all elements of A are also elements of B. In such a case, you can say that set A is subset to B. A is subset to B. A is subset to B. Here, A is subset to B. You can represent like this. In set A, 1, 2, 3 are the elements, and in set B, 1, 2, 3 and 4 are the elements. Every element of A is also present in B. In such a case, you can say that the first set is subset to second set. Go for the universal set also. I previously gave an example. Universal set, we took the set of students of a school as universal set. And for this universal set, there are subsets like set of volleyball players, the set of cricket players, the set of kabaddi players, like this. The set of cricket players and the set of volleyball players and the set of kabaddi players are subsets to universal set. Therefore, every set is subset to universal set, and phi is also subset to every set. There are two important points you should note down. Every set is subset to its universal set. And the second point is empty set is subset to every set. Now, let us know the different operations on sets. Let us know the different operations on sets. The first one is union of sets. Union of two or more sets is the set of all elements that are present in any one of these sets. For example, here if you consider the set A as set 1, 2 and B is equal to set 2, 3, 4, then A union B is equal to set 1, 2, 3, 4. You see, union of sets is nothing but the union of both the elements. I mean the elements that belong to the first set and as well as the elements that belong to the second set. You should list out all the elements that are present in first set and also present in second set. That is called union. The name itself indicates union. Union means the sum of. Therefore, you have to sum up the elements of A and the elements of B, and you have to write them in an order that will be A union B. You see here, A is equal to set 1, 2 and B is equal to set 2, 3, 4. Then A union B is equal to 1, 2, 3 and 4. These are the different elements that are present in first set A and also in second set B. Therefore, union of sets is the union of two or more sets in the set of all elements that are present in any one of the set. This is union. Now, the set builder form. The set builder form of A union B is equal to. Now, if an element belongs to A union B, then it means that element may belong to the first set or it may belong to the second set. You see here, A is equal to set 1, 2 and B is equal to 2, 3, 4. If 1 is present in first set, you wrote in A union B. And 2 is present in both the sets, again you wrote in A union B. And 3 and 4 are not in A but they are in B, even though we wrote in A union B. Therefore, A union B is nothing but the sum of all the elements of the first set and as well as the second set. Therefore, the set builder form of A union B is X such that X belong to A or X belong to B. And now the second operation is intersection of sets. Intersection of two or more sets is the set of elements that are common in all the sets. Intersection of two or more sets is the set of elements that are common in all the sets. For example, if A is equal to set 1, 2, 3 and B is equal to set 2, 3, 4, then A intersection B is equal to. Now we have to list out the elements that are present in both the sets, which are common elements in both the sets. Now what are common in both the sets? The element 2 is in A and also in B. The element 3 is in A and also in B. Therefore, only the elements 2 and 3 are present in both the sets, and A intersection B is equal to set 2, 3. Students, is it clear now? Now, set builder form. The set builder form of A intersection B is X is an element in A intersection B only when X is present in A and also in B. That is X such that X belong to A and X belong to B, means X is common in both the sets A and B. Now, dear students, let us try to distinguish between union of sets and intersection of sets. Union of sets means you have to write all the elements that are present in the first set are also in the second set. Therefore, an element in A union B means it present either in the first set or in the second set. But whereas intersection means it should be common element. That element should present in both the sets. Here you see A intersection B is equal to set 2, 3. Means 2 is an element in the first set and as well as in the second set. And 3 is an element in the first set and as well as in the second set. Then only you can write it in A intersection B. Then the set builder form of A intersection B is X is such that X belong to A and also X belong to B. Means X is a common element in A intersection B. I shall repeat. If we list out all the common elements, then it is intersection of sets. If we write all the elements of the first set and as well as the second set, then it is union of sets. That is the difference between union of the sets and intersection of sets. And the next operation is the difference of sets. The difference of two sets is the set of all elements that are present only in the first set and that are not present in the second set. You see here is an example. If A is equal to set 1, 2, 3 and B is equal to set 2, 3, 4, then A minus B is equal to. A minus B means you have to write the elements that are present in the first set only, which are not in second set. Now, if you observe 1, 2 and 3, these 2 and 3 are also in B. But only 1 is the element that present to first set. Therefore, if you list out all the elements that are present to the first set only, then this is called the difference of sets. Okay. Now, the set builder form of A minus B is X is such that X belong to A and X not belong to B. The set builder form of A minus B is equal to X is such that X belong to the first set A and X does not belong to the second set B. If an element is present in the first set and it does not belong to the second set, then that element should be in A minus B. This is the set build-up form of A minus B. Now we learn three different operations on sets. First is union of sets, second is intersection of sets, and the third is the difference of sets. Union means you have to write all the elements that are present in the first set and as well as in the second set. And intersection means you have to list out the common element that belong to both the sets, that is intersection. And the difference of sets means you have to write the element that belong to the first set only and the element should not belong to second set. Such type of elements which are present in a set is called A minus B. And these are the different operations on sets.